Hello everybody and welcome back, and right now let us continue with our advanced usage of the requests library. Now what we did in the previous video is we saw some of the examples of using session and cookies. We saw how we can actually set our own cookies by the default on that http://bin.org page. We also saw how we can send different authentications. We saw how we can actually change some of the contents of our request headers, and also how we can print the response and the request headers out. Okay, so right now what we're going to do is we're going to take a look at the SSL certification. So right now we are going to open up our idle, open it up, and basically the requests library verifies SSL certificates for HTTPS requests. Just simply the same way as the web browser does that. By the default, the SSL verification is enabled, and the requests will throw an SSL error if it is unable to verify the certificate. So simple as that. Let me just import my requests right here. Press here enter, and let's say you, for example, type requests.get and you specify this page, https google.com, or not google.com, let's go facebook.com. Press here enter, and we will get our response to 100, which means that the page has been loaded successfully. Now let's say, for example, right now we get this page, .get https request.p.in. Press here enter, wait a few seconds. For some reason it is lagging out right here, but doesn't even matter. What matters is that this page does not have an actual certificate enabled. Let me just see right here. What did we get as an error? Max retries connected with caused by new connection error. Okay, it doesn't even matter. What we're going to do is we're going to try to verify with our own request the SSL certificate. So let me just restart this. Because of this error, we will simply just import requests once again. And what we're going to do is we're going to specify, instead of the URL, or besides the URL, we're also going to specify the verify option, which is going to have a directory where the path, where the certificate is, where the SSL certificate is. So right now, requests.get, and let's say, for example, we want to go to https://github.com, comma, and then you simply just specify verify, and you need to specify the path to the actual certificate, which is this one, comma, single quote, and then /path/to, and then /cert file. Press here enter. Could not find a suitable TLS certificate bundle, invalid path. Let me just see. Cert file. Yeah, okay, so it probably isn't at this current path, but once you actually know where the certificate is, you can simply just check the verification with this actual variable right here, or should I say it argument. Simply just specify the path to the directory where your certificate file is, and the requests library will simply perform the check by itself. Now, you can also do it the other way, which is simply just creating the session object, which we did in the previous video. So as equals requests.session, press here enter, we created the session object, and you can simply just specify as.verify, and then in the brackets, or doesn't have to be in the brackets, you press here equal, and then a single quote, and then /path/to /certificate. Now, of course, this basically path is optional. You don't really need to specify it like this. In most of the websites, it will be different path. But let's now see how we can actually disable the verification in our own request. Now, the list of the trusted certificates can also be specified through the request CA bundle environment variable, which we don't really need to take a look at that. But what we should look at is that the request can also ignore verifying the SSL certificate if you set this verify variable right here, either here or either here, if we set it to false. So if I just specify requests.get and I simply specify HTTP / and then some website and then comma, and I specify right after it that the verify should be equal to false. Then it will not go through the directories, it will not try to find the actual SSL certificate, it will simply give us the response to OK, and it will load the page. Now by the default this verify variable is set to true, but you can change it as we saw right here if you for some reason don't really want to actually check for the SSL certificate. Now you can also specify a local certificate to use as a client-side certificate, basically as a single file containing the private key and the certificate itself, or as a tuple of both files. Now how do we do that? Well, I currently don't have a file like that, but I will show you how the syntax goes. Simply you just specify requests.get, and as usual the first argument will always be the website, so specify https //facebook.com, and right after it you want to specify the cert equals open and close normal brackets, and then you type here double quote and /path/client.cert. Well, let's say we name it like that, it doesn't have to be client.cert, but right after it you press here comma, and the next thing is the key, so you specify the key right after the client. Let's say it is something like that, it is called something like this, so /path /path/client key. Okay, so basically this would be the syntax for that. Of course, it says it will not find the TLS certificate file, invalid path /path/client cert, because I don't have it on my current PC. That's why it gives us an error. Now, of course, another way, as we saw right here, you can do that through the session as well. So s equals requests.session. We always create the session object first, and then s.cert equals, and then specify /path/client.cert. Okay, so basically you can do that as well if you want to, like this. Now, if you specify a wrong path or invalid path, you'll get an SSL error. Now, basically we saw right here that right here we could not find suitable TLS certificate bundle, and as well right here we couldn't find the TLS certificate file, invalid path. This is the mostly normal error that you will receive if you don't have the actual certificate, but you can also receive the SSL error, which will, for example, say error number and then something SSL. Basically it will be a different error than this one, just so you know. The errors will not be the same. Now let us take a look at something called body content workflow. Now by the default, when you make a request, the body of a response is downloaded immediately. So once you make a GET request, you will download the body of the response right away. Now you can override this behavior and defer downloading the response body until you access the response content attribute with the stream parameter. So basically it will not store the body until you actually access it or want to access it with the response.content attribute. But let me just restart my idle right here. We got too many errors to actually deal with, and we will simply just import requests, and I will show you how you can actually specify the stream parameter in the actual request. So you have a URL, let's say the URL is https://twitter.com. This is our URL, and we want to perform the request, which we will store in the R variable. So requests.get onto the URL, and then we need to set the stream to be equal to true. Now at this point only the response headers have been downloaded and the connection remains open. Now, hence allowing us to make a content retrieval conditional, which we can do if we want to. For example, you can simply just specify an if condition like this: if integer of the r.headers, and we want to see whether the actual length of the page or the page is big enough, or we actually want to see how big the page is, and we can simply do that just by accessing the response headers, the content length parameter from the response headers, which actually stores the size of the page in bytes, pardon me, and then we need to actually call that parameter right here, which is the content length. We talked about it before. It is stored in the headers themselves, and we simply want to specify, for example, it is smaller or larger. Let me just find where the actual smaller or lesser sign. Okay, so here it is. Smaller than 2_long. Press here 2 dots, and then right here we simply can specify that the content will be equal to r.content print content, for example. Press here enter, and it will say too long is not defined, because of course we don't really have that variable, the too underscore long. You can set to be equal to as many bytes as you want to. I just showed you here the actual example where if the page is smaller than the desired amounts of bytes in the actual page, you can store that into a content variable and then print it afterwards. Now you can simply just access it just like this: r.content, press here enter, and it will say squeeze text 2306 lines, which we already saw before. That's why we will not really print it, because it will actually make our idle lag out. Okay. Now there are also different things you can do, such as streaming uploads, keep alive. Now streaming uploads basically is request supporting streaming uploads. They will allow you to send large streams or files without reading them into memory. Now, in order to do that, basically simply provide a file-like object for your body. So, for example, you open and then specify right here some body. Doesn't even matter, we don't really have it, but if you had it, you can specify it with the name right here, and then you want to read it as bytes. Close the brackets, specify it as f. This is a simple example of opening a file. It is rather simple, or the same, should I say, and you will simply just perform the request right after it. So request.post, and you want to actually add to that body something like, or to a certain URL. We will just specify URL variable right here, so we don't really type some URL, and you want to set the data to send to this actual URL to be equal to f. As we can see right here, we opened this body for reading bytes as f, and then we send the actual post request to a certain URL with the same data, or with the data specified to be f. Okay, let me press here enter. Of course, no such file or directory, somebody. Doesn't even matter. Now another thing that you can do with the requests is that basically requests support chunk transfer encoding for outgoing and incoming requests. Now, to actually send a chunk encoded request, simply provide a generator, or basically any iterator without length, for your body. So let's say we have a function generate. We call a function like that, and all this function does is it yields these two strings, hi and yield there. So this is our entire function. Let's say what happens once we actually call it. It will say generated object at this actual address. Okay, and now if you want to perform the actual request with this actual data, you can simply just specify requests dot post. Let's say we are actually running a post request. to some actual files. So let's say https facebook.com, doesn't even matter, specify any URL you want, and you specify that the data that should be sent is equal to the generate function. Memory, a bytes like object is required, not a string. Yeah, that probably has something to do with the actual link itself. Of course, it will not work right here. As it says right here, you can check it out at memory view, a bytes like object is required, not string. Okay, of course, but this is something that will work sometimes, so make sure to keep that in mind as well if you want to send the chunk encoded requests. So this is the way to do it, okay? But this is also some of the not that important parts for those of you who do not want to actually study the web development. This is not something that you're interested in. This is just some of the more advanced stuff that you can do with Python regarding the requests library. So let me just restart this once again. Now, another thing that you can actually do is you can simply create your custom authentication with the requests library. Now, requests allows you to specify your own authentication mechanism, whether you have it or not. You can create it. Basically, any callable which is passed as the authentication argument to a request method will have the opportunity to modify the request before it is sent out. Now, authentication implementations are subclasses of auth-base, which we will see how we can actually import. Now, from the requests library, we will import auth-base. They're very easy to define, and basically the request provides two common authentication scheme implementations in requests, such as HTTP basic authentication and HTTP digest authentication. Now, let's see how we can actually do that. So simply, in order to just import the auth base, which will allow us to actually create our own authentication, you can simply just specify from requests.auth import auth base. Press here enter, you will see it went without any problem. And let's say we create a class which is going to be our own or custom auth, let's call it like that. It will take the elements of auth base, because the auth base is a class, or basically a parent class, so we can take its actual elements into our own class. We saw how we can do that in the actual studying of classes. We remember the parent classes, the inheritance of different objects from one class to another, and so on and so on. Now, basically, what we want to do is we want to create the init function. So def init, it takes the self argument and the username argument. Press here enter, and then specify that the self.username will be equal to username. Now, this is any authentication related data right here. You can also specify password if you want to, but for now on, let's just stick with the username. Whoops, I closed it a little bit too early, so let us just go once again. Custom auth base, def init, self, comma, username, 2 dots, and then self.username equals username. Press here enter, go one step back, and another function we need is the call function. We need to specify the self argument and R, which will allow us to actually modify and return our own request. Okay, and then R.headers, we want to simply add a header, which is going to be, for example, our custom auth, let's call it like that, doesn't even matter. And all we need to do is specify the actual variable that holds the authentication, which in our case it is only a username. So if you had a password, you would also specify something for the password, but for now on we only have the username, and we want to return the actual response or the request. And then we can make the actual request with the request library by specifying requests.get. Let me just import requests in case it will not work with this thing. So we will just specify requests.get, and in between the brackets you simply specify the URL such as HTTP and then some random website. Of course, this will not work on a random website. This will only work if you have, for example, your own website. And right after it, you need to specify the auth parameter to be equal to your own authentication, and you specify it simply by specifying the class name, which is custom auth, and in between the brackets you need to specify the actual username. As we can see, that is the only thing that we have for the authentication. You can simply specify admin, for example, doesn't even matter, and then after it close another bracket, and you can send this out, which will give us probably an error. Yeah, because it is not an HTTPS website, it doesn't really have any checks, so therefore we actually successfully sent this and got the response 200 OK. Now, basically, this is one of the ways that you can actually custom or define your custom authentication. Now, what we're going to do in the next video is we're going to take a look at the JSON library and also streaming requests. We're going to take a look at how we can set up our own proxies, how we can set up the socks, and so on and so on. So that would be about it for this tutorial. I hope you enjoyed it, and I hope I see you in the next one. Bye!